In this video, I'm going to talk about 6 helpful things that you need when running Kubernetes in production. So let's dive on it right on in. So the first tool that's super helpful to have running is called Lens. Lens is an IDE for Kubernetes, and what it does is it allows you to visualize all of the Kubernetes resources and objects that you have running in your cluster. So you can see right now I'm in the Lens app. I am viewing my demo Kubernetes cluster. And then you have this sidebar here that lists out a bunch of different Kubernetes objects so that we can explore a bit. So right now you can see I have workloads highlighted, and I can see which pods, deployments, etc. are running in my cluster. This is actually segregated by namespace. So if you're just interested in a particular namespace, or you can click all namespaces. And a part of this overview is you can actually see events that have occurred recently. So this is really helpful when troubleshooting and analyzing things. And we can further break this down more by clicking specific deployments here and pods. And then the nice thing that I use pretty often is from this pod list view, you can actually see the node that the pods are running on. And if we click on the specific pod, opens up another window here and provides the same information that you would see with like a kubectl get pods command with the extra like arguments to show you all the details. And you can even do something like look at the pod logs here. And if we go up to nodes, so we can see the nodes that are currently running in our cluster, the version, the Kubernetes version, the age, and we can do the same thing that we did with pods by clicking on the node and getting additional information. And it also has these shortcuts here, so you can coordinate and drain or delete a node. And this is a nice view too, so you can see all of the pods that are running on a particular node. And same thing with the network objects. So you can see the services that are running, IPs associated with them, addresses. So yeah, this really speeds up my productivity and workflow when I'm doing daily things and just analyzing. It's really nice to get a visual of your cluster as opposed to just running a bunch of different kubectl or kubectl commands, however you like to call it. All right, so let's move on to the next thing. So running pod anti-affinity rules is really good to ensure that your application stays highly available and is fault tolerant. So what is anti-affinity? Anti-affinity is a rule that gets added that your kube scheduler analyzes before it places a pod on a node. So when a kube scheduler goes to schedule a pod, first it's going to check if there is already a pod with a label that you have defined on it running on that node. And if there is, then it's not going to run the pod. And let's do a quick example here. So we have our deployment YAML, and we're going to run 2 replicas of this application. And you can see here we have this pod anti-affinity rule defined. So let's deploy this on our application. Sorry, deploy this on our cluster. There we go. And we'll open up Lens to analyze this. And we'll go to our demo namespace. So you can see here we have a deployment that was created with 2 pods. And let's view those pods. So we have pod 1 and pod 2. And if we look over here at the nodes they were placed on, they were actually placed on separate nodes. And that's thanks to our pod anti-affinity rule that we set. So the benefit of this is if this node here goes down, then we still have an instance of our application running on a completely different node. So our application is still going to stay up. This is going to allow users to continue to access the application. If we didn't have an anti-affinity rule and both pods were placed on the same node and this node goes down, well, then no one can access our application. Our availability goes down to 0% and customers are not happy. So let's do another little, let's further dive into this example a bit. And you can see here we have this argument set and it says required during scheduling. So this required during scheduling means that if it can't find a node for the pod to be placed on, then the pod is just not going to be scheduled at all. It's going to be stuck in pending until another node comes up that fits this criteria. So don't take my word for it. Let's actually see this in action. So I'm going to change the replica count to 5 here so we can play around. Let's apply this and look back at our cluster. So you can see here that 3 new pods were just created, but they're all in the pending state. And if we see why, we can look at this little caution icon. And it mentions 0 out of 2 nodes are available. 2 nodes didn't match pod anti-affinity rules. So the kube scheduler saw, oh, hey, I already have a pod with these specific labels running. Let's see right here with these labels running on this node and this node. So I'm not going to place these. So this is a good strategy to ensure that we only have one pod of the same deployment running per node, but it's also a little bit harsh because let's say we do want to have some more replicas running and we only have 2 nodes available. We may want to do that. So there's another strategy that Kubernetes offers us, and instead of required during scheduling, we can set it to be preferred during scheduling. So what this means is the kube scheduler will try to put the pod on its own node, but if there's not one available, it's going to say, hey, I tried, but I'm going to run you anyway. So let's apply this updated configuration to the cluster. And let's take a look. So we have these pods here that are impending. All right, don't see any changes yet. Oh, let me apply the right YAML file. All right, there we go. So now it looks like all the pods rolled and they all got placed. And if we take a look at one of the pods, you can actually see the affinities that are configured for it. So if we click show, you can see here, this rule that we defined gets passed onto the pod. So yeah, if you want an option where you want, more replicas running, and you want to, make sure that they are, at least some of them are separated, but still run them if they're not, then we can use that preferred option. All right, next up. So I want to talk about something called Cluster Autoscaler. So what Cluster Autoscaler is a tool that automatically adjusts the size of the Kubernetes cluster, depending on if you need more nodes or if some nodes are not being fully utilized, it will actually remove the node for you. So let's take a look at how this works. So say that we create a new application. So we want to deploy some pods, but there's no nodes available. So the pods are going to be in a pending state due to insufficient resources. Then cluster autoscaler is going to see that there are some pods in pending. So it's going to say, hey, let me contact the ASG and increase the desired number of instances. And then AWS autoscaling is going to kick in and provision a new node into the cluster. And then once that node is up, ready, and healthy, then that pod is going to be placed. And that same cycle keeps happening if more pods are stuck in the pending state and there's no nodes available for them. And it scales down nodes if, let's say, this node is only at 10% utilization, but there's another node in the cluster that has room for the pods that are running here. It's actually going to cordon the node, that way no new pods can run on it. Then it will drain the node, which kicks off the existing pods here onto the other node in the cluster, and then it will delete this node. And the reason why it scales down nodes is to save us money. So we don't want to be running a bunch of nodes that are all underutilized, because AWS charges by the hour for these nodes. So we want to make sure that we optimize our costs, as well as ensure that our applications are highly available and always have a node to run on. So that was a little bit quicker than the whole pod anti-affinity rules. Next thing I wanted to talk about is called Helm. So Helm is the package manager for Kubernetes. What does that mean? So Helm is a way to easily install software into a Kubernetes cluster, and it kind of abstracts some of the details and makes things specifically for Kubernetes. So defining things as a pod, defining tolerations, taints, even things like affinities that we just talked about can be defined in a Helm chart. And let's show a quick example of like installing a piece of software into our cluster using Helm, so you can kind of get a sense of how easy it is. So let's go to our terminal and let's run this Helm install command. So Helm install, then this is going to be the name of what you want to name the software you're installing. And then this here is a repo, and then the software in the repo. So it provided us some output. So let's go take a look in the cluster and see. Yeah, so you can see that we just installed cluster autoscaler into our Kubernetes cluster with a one-line command. Super quick, and this is the most popular way that developers, SRE, DevOps folks install software into their Kubernetes clusters. And the next tool that I'd like to show is called RBAC Manager. This tool is kind of advanced with its topics and with what it does. It's created by the Fairwinds Ops team. So thank you folks for that. And what it does is it manages the creation of role bindings for Kubernetes users. With this, you can automate the creation of per namespace security rules to ensure your cluster stays secure and engineers have access to the things they need and restrict access to the things they don't. So I made a little picture to try to visualize what RBAC Manager does. So let's say that a new namespace gets created here, and you can see that we have some labels on this namespace. RBAC Manager is actually going to see, oh, hey, this new namespace got created, and it has a label of app equals project A that I was told to watch for. So then RBAC Manager is actually going to create a role binding for this namespace, so to this cluster role here. And then this allows for, anyone who is allowed to use this cluster role to also have access to these namespace resources. This takes away a lot of the, manual processes that you would have to do to create role bindings for every new namespace that got created, if that's something that you would do at your organization. And last but not least, when it comes to upgrading your Kubernetes cluster, we will take all the help we can get. And in this case, there is a script called the EKS rolling update. As its name implies, it's for EKS, which is the Amazon version of Kubernetes. So it's specific to that, but Amazon is the most popular cloud provider at the moment. So I know a lot of folks can get use out of this. It was created and maintained by the folks over at HelloFresh. And what this is it's a script that when you make a change to your launch configuration, you can run this script and it will be able to tell that there's a change, and it is going to apply the um, desired state of your launch configuration in a high availability fashion. So it's going to create a whole new set of nodes with the new AMI or EKS version that you are updated, and then it will cordon the outdated worker nodes. It will drain the outdated worker nodes one by one. So it's going to remove the pods from these outdated workers, and it will put it on the new nodes. And then it's going to go ahead and terminate those old EC2 instances one by one after the pods are off of them. And then once it's done, it will scale the ASG down back to the original count and resume auto scaling activities. And yeah, this is a really nice way so that you don't have to manually cordon, drain, and also increase the your ASG size. So this just automates getting those new worker groups out there. All right, and that was the last tool that I wanted to go over. I hope that this helps some of you, make your day-to-day life easier, and maybe implement some new things in your workplace. Let me know if you want me to go more in depth in any of these tools, and can make some future videos on more specifically on how to use these tools. But for today, that's it. Thank you all for watching.